Welcome to the Flux Dev Meeting for September 24th.
Hello, everyone. Have some great news. We are on track with Flux 2.7 release. And I think so far there are no blockers. Yesterday we ran the conformance tests with Kubernetes 134. Everything was fine. So today we are moving forward with releasing all the controllers, and next step is running the benchmark. Hopefully there are no performance regressions. And if that works fine, then early next week we'll have a 2.7 release. This release is quite special from two perspectives. One, we are, I think for the first time in 5 years, we are adding a new controller to the Flux distribution, and two new APIs. We had this controller for a long time as an example for people on how to build their own controllers. It's called Source Watcher, and we have repurposed it as a controller that watches Flux sources and can do some very interesting things with sources. For example, we had since forever this problem with monorepos, right? You have a monorepo, tons of services in there, and you need to, deploy, let's say, hundreds of microservices from this monorepo. One of the major challenges here is that every time you make a change in any file in that monorepo, all the Flux customizations will do a dry run, and only the one that detects a change will actually do an apply on the cluster. The problem here is there are two problems here. One is you get basically a storm of events because all your customizations will be reconciled. And second, if you run your own Kubernetes control plane, the dry run can be quite expensive, and it can at times put a lot of pressure on the API. The control plane becomes slower, and that would result in a slow rollout. If you have 1,000 Flux customizations, doing a dry run for each one can take, I don't know, 10 minutes more in order to deploy a change. What solution we had so far for this use case was to not connect Flux to Git anymore and create this CI setup where a CI job will detect if something changes in a directory. You'll bundle that directory in a Flux OCI artifact, push that to the registry, and that will trigger the reconciliation of a single Flux customization on the server. What we observe is that some people don't want to switch to OCI from Git due to various reasons, and others, it's more about you need to refactor everything in order to deal with one source per microservice. So this is one, let's say, bottleneck we had in Flux before Flux 2.7. Another situation is where you have So in this first case where you have this monorepo and you have hundreds of customizations, what you would like to do is decompose the repo somehow inside the cluster. So only one Flux customization will reconcile the one that belongs to a change in a file. Another use case is the opposite. You have multiple sources and you want to bundle them together and apply them as a single deployment unit. And this happens when you want to do, for example, operations with Helm. There's a use case where, let's say, you have a Helm chart as an OCI artifact. Then you have some values that you want to use for that with that chart in your Helm release. Now, in order to do that, you would need to use Flux customization that has the source, the Git repo, and you need to use a config map generator or a secret generator to, get the values YAML from the Git repo and put it there. So in a way, you are forced into understanding how generators work, have the Helm release definition and the config map in the same source, because the generator has to patch the Helm release and so on. One major change we are shipping in Flux 2.7 around this is Flux can now watch values from references. So you don't need to keep the Helm release definition and your values YAML in the same repo. But still you need, to create a Git source, create a Flux customization that applies the values, and another one that applies the Helm release.
Funny that
So
you're talking about that feature right now. I am just writing the paragraph in the changelog for notification controller release notes about this feature as well.
right. So yeah, we in Flux 2.7 we are adding two new APIs. One API in source controller, which is called external artifact. And there is a whole RFC. We talked about this before. Basically, it allows you to swap source controller with your own implementation. And now we are adding the source watcher as an optional component to Flux, which comes with a new API called artifact generator. And this artifact generator, what it does, it can watch Flux sources, let's say an OCI repository which contains a Helm chart and a Git repository which contains values. And you can tell a source watcher to bundle these two sources into a single one and present that in the cluster to Helm controller as an external artifact. So what you can do with it to solve the issue I was talking before, you can say, get the chart from the OCI artifact, get some values YAML from a Git repo, replace the values YAML inside the chart, and rebuild the chart for Helm controller to use it, right? So you no longer need a Flux customization that applies that. You don't need to create a config map from it. Then you have to reference it in the Helm release and so on. You can just swap the values YAML or merge the existing values YAML in the chart with this one or more values YAML coming from any other source, repackaging it and present it to Helm controller as the original chart. And this approach basically can simplify a lot the way you have to, organize your repos and the number of Flux customizations that you need to create. So that's one use case where artifact generator is useful, which is called source composition. Now, for the first use case I mentioned, where you have this huge monorepo and you want to split it by directories, and when you make a change in a directory, you don't want to reconcile everything. Artifact generator has this decomposition feature where you can say, watch for this Git repo source, then create a Flux artifact for each directory. Then you'll have all these Flux customizations. Instead of using the single Git repo as the source, they will use this artifact generated in the cluster. The advantage here is that the external artifacts created by SourceWatcher and the artifact generator custom resource, their digest matches, their revision matches the digests of the content of the artifact. So if you change something in a directory, you do a commit, then the artifacts produced will not have the revision that commit, will have the revision equal to their contents digest. So if only one directory changes, only the Flux customization that has that source, the artifact with the directory, only that will reconcile. So that's one major improvement for people dealing with these use cases. Just to mention that even if you decompose a Git repo, you'll still want maybe to write back to the repository Git status commit, right? It's something that a lot of Flux users are doing and so on. So how we accomplish this, artifact generator can attach the upstream revision, the Git SHA, to the external artifact that it generates. And when customized controller will upgrade an app, the event will contain this SHA. So you can still use Git commit updates. You can still get meaningful notifications on Slack and so on, because you can actually configure that the origin revision is the one from upstream. So you don't lose visibility in, from where a thing has been reconciled and so on. And we also have improved the Flux trace command. If you use a Flux customization that has a source, an external artifact, when you run Flux trace for, let's say, a pod or a deployment, it will show you not only the external artifact as the source of that, but also its upstream source. So you always know, oh, this external artifact was created from this source. So yeah, that's those are the major improvements, let's say, that we've been working on in the last month and will be part of Flux 2.7. What are you doing, Mateus? Are you playing?
No, I'm looking at the LinkedIn post.
Oh, that was your phone. I thought you had like a Game Boy or something.
I have a couple here at home, but I'm not using them right now.
If we could get Flux running on a Game Boy, that'd be pretty impressive. I took some notes from this convo. I didn't really think about the decomposition use case when I was looking at a external artifact. That's a really important one. Do you do that by just making 100 external artifacts and then
Yes.
all point to the
Yeah,
same info and
just consume whatever sources you want and output whatever artifacts you want. So it can be one source with many artifacts.
That's you just use the copy, the file copy feature to only get what
Yeah.
you.
Yeah, it's in the docs. Have you seen the repo?
I
Can
think
you
I
go on the repo?
looked at for Source Watcher. I only looked at the README, the example that was there a couple of days ago of composing things together.
It supports copying files and also merging YAML.
Mm-hmm.
So does the example include any sort of guide about how to fan out and do those 100 resources with resource set? Or is that possible?
It is, of course.
Yeah.
Yeah, if you have, Lee, can you let me share my screen?
Yeah. Mm.
Can you see my screen?
Yep.
We
Yes.
can.
Okay.
Yes.
So this is the source watcher repo, and there are two examples here. So one, which I mentioned, composing multiple sources. So I have here a list of sources. Here is a Git repo, OCI repository, a bucket. Let's say something repo has some app or part of your product, let's say a microservice, some other OCI repo has another microservice, maybe in a bucket you keep configurations and so on, and you want to mix them all in a customized overlay. You define your sources here. Let me make this bigger. You define your sources here, and here you can say, hey, from backend, put it in this directory, from this, put it into this directory, and I don't know, you can also rename files and so on. So this is basically how you compress multiple sources in a single artifact, which is called my app composite. And then if you want to apply this, you create a customization where the source ref is kind external artifact, my app composite, right? Now, for what we've been talking on is monorepo decomposition. Here you'll have a single source, your monorepo. Then under artifacts, you can define how many artifacts you want. And with the copy command, you say, copy from my monorepo from this directory, everything which all the subdirectories, and put it in the artifact root. So this will create a policy external artifact source that you can use in your Flux customization. Then you can have an auth service, which is in a different path and so on. And you can have here as many artifacts as you want from the source. Of course, you can wrap this artifact generator in a resource set and have all of these templated. Another example was this Helm chart composition, where I have the OCI repository, which is, let's say, the upstream chart. I can't modify it. It comes from external. And in my Git repo, I have some values file. Here you'll create a single artifact. You set the origin revision to the chart, for example. So when you send notification, when you receive notification, you know the chart version from upstream. But here, first you copy the chart content to the artifact. Then from the repository, you can directly override the values YAML, the default values YAML in the chart, or it's up to you how you want to do it. You can have other values like values prod, like something which is widely used for Binami charts and so on. Lots of charts have this stuff where there is a subset of the values which contain some, different optimization for a particular environment. And you have this strategy called merge, which merges the values prod YAML into the existing values YAML. And this strategy is exactly what Helm upgrade or Helm install minus values does, right? It collapses everything into the final values, and it's compatible one-on-one with the Helm CLI, or how Helm controller does the merging of values from. Right. So the result of this is a external
Interesting.
artifact called podinfo composition. And here you don't have to set values from some config map where you have the values prod YAML, because you have already bundled it in the chart here stream. And how is this useful? Is for there are kind of two types of users here, right? It's let's say the platform admins, which want to give you vetted charts with vetted configuration. In order to do this today, you'll have to fork an upstream chart, replace the default values YAML with your own, rebundle it, and then allow your devs to consume it in a Helm release where they will set their own values. So instead of doing this vendoring, replacing, pushing to your own OCI registry, you can use now an artifact generator. You point it to the upstream chart, and then you can change here any file. You can also change templates or whatever. It doesn't matter. It's these are file operations. But of course, the strategy merge will only work for fully not templates, but valid YAML. And this is specifically built for Helm values because it uses the same strategy. Let me show you
Stefan,
another example
I
of
hadn't
decomposition.
looked at was do the revisions of all of the sources end up in the status of the external artifact, presumably? I'm guessing
No,
that they don't.
no, of course not. You decide. You can pick one.
Yeah, I'm curious about use cases people might have where they might have a bunch of repos here, maybe more than 10 or something, and they might want revisions from more than one. Um,
You can't have that.
yeah.
Flux does not understand multiple revisions, so that's not an option.
Yeah, it's less about only having one revision in metadata and more about, yeah, like knowing what revisions we're at for a particular composition from the status, if you know what I'm saying.
Let me look at the status.
Like if something's broken and then I go find this external artifact in the cluster, like how do I know like what it's reconciled?
I mean, the generator events will tell you. But yeah, maybe we can add the revision to the artifact generator status.
Hmm.
We'll see. We need people to use it and see what are their needs. So yeah, I
It feels like
have
a
here.
reasonable amount of information to put in status since it would just scale with.
We have status.observed sources digest.
Yeah,
Is
but it's one digest for everything.
Yeah.
There's not for
Oh, yeah, right. So, this.
Yeah, so it's like it's nice because the amount of data is so small, but then it's not granular enough to let you know provenantly what things came from for the list of repos.
I
With
guess we could
yeah.
have,
the
what if
more
we
repos that
had,
are there, the bigger of a problem that would be.
what
'Cause
if we had status.artifacts as a list of objects, and those objects are exactly the artifact objects that we put in status.artifact in the external artifact object.
No, too many artifacts.
yeah, and this is less about the
Oh, this
revision of its.
this doesn't solve the problem, right? Yeah.
Yeah, it's less about what's being produced and more about what's
Yeah,
being.
yeah, yeah.
Okay, well, I mean,
But what's
Yeah.
being produced, it's already traced in status, so it's not
yeah.
that's not a problem.
Yeah.
Yeah, we can come up with some history concept like we have in the hand release status, now in the Flux customization, starting with 2.7, where we can actually snapshot all the sources and add them to a, let's say, a history map where you have kind, name, namespace, and origin revision used to produce one or more artifacts or whatever you are doing,
Yeah.
right? But having that only in status is not that useful. It needs to be propagated somehow in Flux trace and other parts. But for decomposition, we are covered here with the origin revision, because in the decomposition
Yeah.
case where you have a single huge monorepo, you can set this origin revision and the alias of your source, and this one will be added as metadata to the external artifact, from where customized controller picks it up, annotates its own events. When they are sent to notification controller, the notification controller adds them to the alerts or the Git status and so on. So, for example, let's say this one, right? You have the Git repo, you have front end and back end here. You only change the front end. The front end artifact will be only this one will be rebuilt. Only this Flux customization will reconcile, but the event will contain, because it's origin revision there, will contain the git commit of this Git repository. So if you set up a provider of type GitHub, let's say, or GitLab, to listen to these events, you will see on the commit the check frontend was deployed, and you will not see backend because you haven't changed anything in backend. So that customization will not be triggered, will not issue a commit status update. And this also helps a lot reducing the the amount of events and the noise basically on your Git repo, where right now if you have two Flux customizations pointing to this source directly, you'll always have two Git commit status updates, one for frontend, one from backend, even if you only changed frontend, for example. So I'm quite pleased with this decomposition example that solves some of the pains of running Flux on huge monorepos. But also the composition one, because there were lots of people in the past who said, I want to combine not only Git repositories. So we have this, for a very long time, we have this include feature for Git repos, which mimics Git submodules, right? Where you can combine multiple Git repos in a single Flux artifact. Now, what people are saying was, oh yeah, that's great, but my base overlay for some customization is not in a Git repo. It's in an OCI repository, and in the Git repo, I'm storing my overlays. How
Mhm.
can I combine these two things, which are completely different in terms of sources in source control? How can I combine them into a single customization? It was impossible, because Git repository include was we designed it to replace Git submodules. Well, a Git submodule cannot come from a S3 bucket. It can only come from Git. It's a Git thing, right? So we were kind of stuck there for, I don't know, that those requests were like 3-4 years ago. And we are finally solving this use case now with Artifact Generator, where you can combine any number of sources and you can layer the final artifact exactly how you want it.
Mhm.
the one major detail here is that the operations, the copy operations here are executed in the order in the array, which means you can override stuff. You can copy something here, you create a file, then in the next operation, you can override the file or you can merge the file, right? Using a YAML merge. So it
Yeah,
gives you a lot of power of, I want to
is
swap some files.
this is the
I
first
no.
time that Flux is actually file system aware. Like the only thing you could do before is filter.
Yeah.
But now you actually can meta program around the file system of your sources, which has been a feature set that many people have reached for and then found is not there because it was not designed that way, right? Like Flux is very much Kubernetes resource model. So it's like whatever's in the group version, kind name, namespace stuff. It doesn't matter what the file name is typically, or where it is in the repo. That's like you kind of just split things up. But now, like you can imperatively program on top of the structure of the repo. Like another use case that's possible here is if an external artifact is the bootstrap source of your cluster, then you can point to a particular file inside of, say, a bucket or an OCI repo, and that can be your service discovery for how values for that cluster are distributed. Traditionally, we've done this with like a config map or something, and then you have to like do customized vars templating and that kind of thing. But now that like that service discovery file could be any number of inputs. It could be like an input list into a resource set. It could activate customizations or it could turn paths on or off. Um, and like this could be your cluster discovery mechanism or your cluster configuration mechanism.
The use case that Lee has been characterizing is one that I was tossing around in my mind also. So, is anybody using this feature yet, Stefan?
This feature was built last week.
Oh, okay.
Who can use
Because
it? I've used it, yeah,
okay.
while developing it.
Because at
This
Deutsche
is coming
Telekom,
in Flux 2.7.
yeah. Now, Deutsche Telekom have what is called Technology Delivery International, and they are operating a central repository for various operating companies of Deutsche Telekom across Eastern Europe, where this use case would make perfect sense. So I'm going to suggest for them to look into it.
Yeah, it gives you so one of the problems with customize and how Flux customized controller works is that you need to layer all the things in your original source ahead of time. There is no way of relayering something in the cluster, right? If you have your base directory here and your overlay is, I don't know, down here, 10 directories below, you need to ship everything to customize controller to get the base from here and apply the overlay here, right? And if you have like these huge repos, you need to, bundle everything, even if it's an OCI artifact. You need to bundle everything there or uh, do some file transformation in your CI before you do the Flux push. Now with the artifact generator, you can actually say, I want to take this directory from here, put it in the root of the artifact, and take this other directory from whatever other path in the repo and put it in the overlay directory in the artifact, right? So you can, no matter what, you can reshape the file system, the file structure of your overlays inside the cluster. removing things, adding things, overriding things, merging things, right? What I think the major challenge with this approach, how I see it today, is this gives you a huge flexibility of messing with the file system. Problem is that, with power comes also danger. How
Yeah,
are you
but
going to test all
Things
these
to
copy
debug.
operations? Yeah,
yeah, but see, for
right.
that matter, the TDI use case, I think, is a perfect fit for this one because they have a central organization that would test and check out all of their cloud native applications because before they're being made available to any of the local operating companies. And all the local operating companies are allowed to do is apply some customization to adjust the behavior of those applications to specific rules and regulations that may exist in the various countries. So even that type of customization is something that you can um, control by way of rules or by a central oversight. So yeah, just like I said, I'm going to point this out to the folks at DT and see if this is something that they will run with.
Yeah.
To your last point on testing, Stefan, we don't have. I mean, maybe a Flux build
I
subcommand
was thinking the same thing. We should.
here. It
Yeah,
also
so
like messing with files and like doing things like in the cluster. There's maybe an opportunity here for there to be a source type that's like Kubernetes resource, or even like a list of Kubernetes resources, some Kubernetes verb, since there's probably a service account name on this object, maybe not.
no.
But or well,
This is
the
this
Kubernetes.
is pure file system operations. Has nothing to do. This controller does not talk to the Kubernetes API. It will never apply anything. The only thing
Yeah.
it does, it watches sources and it
So
creates external artifacts.
say I write an external artifact controller that reflects Kubernetes resources into a source, right? Like another use case this enables is like the BGP peer list, generation thing. Like you want to pass BGP peers as like values to Helm or something, right? Like that.
There's an issue open for supporting external artifacts as a source as well.
Yeah, it has nothing to do with what Lee is saying. So Lee is saying here you could have sources as existing objects in the cluster that you
Oh,
do some transformation on them and you put them in the artifact in a different thing. Like,
but you could have a
um,
controller that produces external artifacts based on objects, for example.
Yes.
yeah.
That's what I'm getting at is
So if you do, then when we implement the external artifact as a source, that will be possible.
Yeah,
it's
we
there's been
have two
so many times
issues.
where I wrote like a Kubernetes job to slurp some information into a secret so that some other thing could use it. And yeah, like this would be a formal way of doing that.
Yeah,
Yeah,
we basically,
so
yeah.
we have two issues here. One for the Flux 2.8. One is allowing external artifacts as a source in artifact generator. Like maybe there are by Flux 2.8, maybe there are other source controllers out there. They will create their artifacts. What if you want to get the manifest from there, do some copy transformations, merge them with other Flux sources and produce some other artifacts? So this is definitely going to get into Source Watcher where it can watch its external artifacts produced by things which are not Source Watcher, right? And the other one is allowing to do transformation on Helm chart objects. Maybe you don't have the Helm chart in an OCI repo, you have it in old school HTTPS repo, but you still want to do transformations inside the chart and repackaging it, swapping values files, adding, I don't know, policies or other things to the final chart from other sources. So that will also this will be very, very easy, both of them to add them to Source Watcher, and it will enable other use cases. For the UX part, I really think we need a Flux build command where you'll map these sources to local directories.
Mm.
So you do a git checkout of the backend, you do a Flux push of the front end on your local machine. You clone the bucket locally with a S3 command line or whatever. So you have this locally on your file system.
Mm.
Then you run Flux build artifact generator my app -- source git repository backend equals the path where it is on your local machine, this one, and when you run build, it will create on your local machine, in this case, a single directory called my app composite with all the files inside. If you do this one, decomposition, basically here you will clone a single git repo, your mono repo, and the build command will create 3 directories for every single artifact. Then you can, figure out, am I copying the right things? Are these things, can I do a customized build on them? All the stuff that you will want to do for, static analysis, debugging, figuring out if the merge, if merging YAMLs is the actual thing that you want or not, and so on.
It's kind of funny.
Exclude,
It feels like
and so on.
just looking at it sort of reminds me of BuildKit a little bit. Just like
Yeah,
naming stages, like, yeah.
you can, like for BuildKit, this will not be artifacts. This will be layers inside an artifact, right? Because BuildKit produces one artifact at the end, and this would be layers
Uh,
inside that artifact.
uh,
Uh,
not like you can target different stages for BuildKit to output stuff. So you can get multi-in, multi-out.
mm, yeah, of course. But how I think of BuildKit is, these are the copy operation in your Docker file.
Yeah.
Every step here results in a layer, and the final artifact is a composition of all these layers stitched together. In our case, there are different artifacts, or this will look more like what BuildKit is doing, right? All these layers which can override themselves, and they end up in a single thing. So one more thing that I wanted to brainstorm a little around this. So for here, for the Helm chart composition, right? We have this strategy. This is the default strategy for everything, which is called override.
Mhm.
So if you put some files in the artifact, then from the same source or a different source, you end up with the same destination path. By default, what we are doing is overriding the file from the previous copy operation. So this was the first implementation I did. And then it became obvious it's not enough, especially when you deal with Helm charts, because usually values like these values prot, for example, don't have an exact copy of all the values. They are a subset of the values. Right? So I said, okay, like if you override the default values with the subset, of course, the Helm build will fail. Helm controller will say, there are all these things in templates, which the templates can't be built, right? So I've implemented this strategy called merge, which is a one-on-one with what Helm does for values file. And what Helm does for values file is a map merge, a deep map merge. What this means, and I've documented here, okay. So I documented here at copy strategy. What the merge does will always replace arrays entirely, because there is no way of how you can merge two YAML files without an open API spec. The only way to do a deep merge is you override everything which is not a map, in case arrays. And this is how Helm values work. Everybody's happy with it because everybody is aware of this limitation. Now, the problem is, what if you don't have Helm values that you want to merge? Maybe there are other types of YAML, like Kubernetes manifests.
Mhm. And I just got done talking about this limitation in customize on an internal thread that I
Oh yeah, it's well known. Like if your open API spec does not have a merge by key annotation, does not tell the merge will override arrays always, because it does not know what is the unique key, when you should do an override and when you should do an append, right? For example, the Kubernetes pod spec has an annotation in Open API spec where it tells the merger that the containers array has a name field, and the name field should be used as the key for merge it or append, right? So if you have in the original YAML two containers, name A, name B, and in your copy operation, you have a different YAML with three containers, A, B, and C. A and B will be merged with a deep merge map, like values, but C will be appended, right?
Yeah, it's the
Which
strategic merge.
strategic merge is called in Kubernetes, right?
Yeah.
Now, the problem with strategic merge is strategic merge will needs open API schemas for the objects it acts on. And there are two things here. The controller will need access to Kubernetes API, and you'll basically use the discovery client to fetch all the schemas registered on the cluster, all the CRDs. It downloads all the CRDs. It extracts the Open API schema from them. That means at least 3 times in memory every single CRD object. I think is more than 3 times. I've calculated at some point, because Helm does this at some point when it builds the templates. And it's a huge amount of traffic and memory involved here. The more CRDs you have, the slower this thing is, the more memory you use, and so on. So I'm now debating if we should have here strategic merge as an option to merge
Hmm.
with maybe not one but two. So I have written a merge implementation which works offline. You don't need to call the Kubernetes API. Why? Because this is a Kubernetes controller, and I can, in client Go, there is a sub package of client Go, which contains all the OpenAPI schema, Go native, inside the package. So I can do strategic merge for all the native Kubernetes APIs without having to instantiate a discovery client, download all the API spec from the Kubernetes API, and so on. So we could have offline strategic merge, let's say, as a strategy that will only work for Kubernetes native objects on the version of the client Go package. So let's say we try always to be on the latest Kubernetes version. That means if you use Source Watcher tomorrow and we implement this offline strategy merge, it will know about deployment version 1 with all the fields, everything in 134, right? Kubernetes keeps adding fields to GA objects, right? So as long as we keep Source Watcher in sync with Kubernetes releases, and now Source Watcher is part of Flux, and we kind of do that after every Kubernetes release. Couple of weeks we do a Flux release. An offline strategic merge will always work for the latest thing, so it will always know all the new fields and how to merge them. I've also implemented the
You won't get gateway API, but yeah.
Yeah. Not gateway. Gateway API is not part of the built-in, right?
Yeah.
So this is the major limitation. For if we want to do a strategic merge, which has no cost, zero, to memory usage, to network traffic, to Kubernetes API and so on, we could create this, implement this based on the client Go Open API definitions. We could also implement an online strategic merge where we call the Kubernetes API and do the discovery part, but we need to do it smarter than Helm. We need to have caching in here, right? Because otherwise, what will happen every time any source changes in your artifacts, in your generated artifact generators, and you can have thousands of those. That means the controller will do thousands of API requests to fetch the same CRDs, load, transform into memory to get the open API spec, and so on, right? Now, the problem is with caching, is the problem with caching. How the hell are you going to invalidate them? When do you know that there is a new CRD or there is a new API version in a CRD or some API version in some CRD has changed? So maybe we can build a watcher for this, like we did for secrets and config maps. We build our own cache of open API specs. Then we have a watcher that tells us the unique ID of the CRD. We don't fetch the CRD through the watcher. We know that it has changed. We receive the unique ID. And based on that, we remove it from the cache. So the next time some artifacts needs rebuilding, if it uses online strategic merge, that API spec will not be in the cache and it will go and fetch only that one, right?
So a third idea, just so that doesn't escape context is I was comparing this to what we do in customized controller in my head as you were talking, because I was just thinking about this. So like customize the CLI has the option to pass an open API spec for pre-validation client side. I think we don't do that because we have nothing like this, right? We don't have like a cache that goes and gets the most up-to-date open API spec. So the validation in customized controller, it happens through the API server dry run.
Yes.
What if we used API server dry run when doing strategic merge?
Here in artifact generator,
Yes. To produce
we
the
can't do that
file.
because dry run is not a verb in RBAC. That means source watcher will need cluster admin,
Yeah. Because
which
in
is
order, okay, cool.
no.
Um,
And
so
I think
just do it all client side by with the open API specs and just implement it in a similar way to API server. Yeah, that's fine with me.
I mean, no, we don't need to implement anything. It's already implemented in the discovery client. So the
Yeah,
discovery client,
the code is similar to what would happen. Like it's all
the discovery client has everything that we need. The strategic merge package from client Go takes as a input the discovery client. So
yes,
everything is already layered in client Go. What the major problem there is, if you every time you instantiate the discovery client, of course, is a new instance, it will make a call.
but
If you
why wouldn't we keep the discovery client around? And does it not have a way to refresh itself?
yeah, it does.
That seems like like a oversight.
It's not, because I actually looked up this. Why it is like this? Because it's used in kubectl, and kubectl it's a CLI, right? You do an apply, it dies. You do another apply, it starts again. So what kubectl does, it stores a cache of all the CRDs of their open API spec on your local machine in a directory. Looks first in the directory that you have on your local machine. You can look, is in .cube/cache.
Yeah.
So if it doesn't find the file there, it instantiates the discovery client, gets the API, and stores it locally. The biggest problem with this is kubectl has no clue that something has been removed or something has been upgraded. That's why when, let's say, you have Helm release v2 beta 1 on the cluster, you do a kubectl get Helm releases. The first time you do it, kubectl does not have that definition, calls the discovery client, stores it locally, caches locally, perfect. Then you upgrade Flux, Helm release v2. You do kubectl get, what kubectl will give you? v2 beta 1. You need to delete the cache with manually to force it to understand that there is a new version, right?
Yeah.
That's a known issue, and I think it's not a problem for a tool like kubectl, which is a CLI. It's okay. How often do you upgrade CRDs? You just wipe your cache, your local cache, and so on. We can't afford such a thing here in the controller because it needs to maintain its own cache, and it needs to be up to date with what's happening in the cluster. And things happen very fast in the cluster, especially at cluster bootstrap. You know, you have a customization that has an external artifact as a source that applies, let's say, some CRDs or upgrades some CRDs. Then you have an artifact generator that merges two custom resources, which you are also upgraded. right? So this kind of reconciliation can happen in milliseconds after the CRD has been agreed or applied, right? And what's the result of not having the correct API spec? Is it defaults to merge. Arrays will be replaced. So if you don't have it, you'll end up with different results that can be like really, really bad and very impactful for your whole structure. If we introduce something like online strategic merge, then we need to be accurate. We can't say, oh, you need to restart the controller or wait a little bit until the cache is expired and so on. We really need to make it proper, where source watcher should react immediately to a CRD change and cache the API spec for it. Otherwise, just because replacing arrays can be extremely dangerous if you don't know that this will happen. Like one example is the self-validation admission webhook, right? It has a bunch of arrays in there with the policies. What if you use artifact generator to merge two policies, right? And if we don't, and you
You
upgrade the
failed to open
cluster
up
or
something.
whatever, you'll end up with less policies that you want. And then, I mean, can be a major security issue, right? Or many other examples where you can get down, applications can go down because, an array that should be merged end up being overwritten. So
Yeah, I think one that would really suck would be like a a database bootstrap. Like oftentimes like that needs to start with a full list. Like you don't just get to redo that list. Very imperative workflows. Lists of jobs that all should have started at around the same time, and then now you're gonna add them 5 minutes later. That it's just not gonna execute properly.
yeah,
Imperative work. I think with most security policy stuff, it would be hard to actually find something where the cluster was in a worse state on Bootstrap before than after, because things would typically be failing closed. But I think the upstra the upgrade use case seems really bad, because if you have a new version of a CRD and you didn't find the merge key for a migrated field or something, then
yeah.
something where the policy was previously a list of things that were being blocked or something. Usually they're more like allow lists, but I feel like things would be more likely to lose access than to grant access, but
No, no, no. No, think about the cell admission. So let's say,
oh yeah.
take this
Typically
example.
admission is typically,
Here is one.
yeah. Yeah.
So here in the source, you are adding a new enforcement to the policy here, which has 10 enforcements.
Mm-hmm.
If instead of strategic merge, let's say you don't have the API spec or the API spec is old,
Yeah.
instead of appending one new rule to all the rules, what you are going to do is you delete all the existing rules and you replace them with one rule. It will fail open. You open the world to everything, but just one rule that you wanted to add. So it's like replacing arrays, especially with policies, can be very, very impactful, right? So I'm considering, adding this online strategic merge only if we find a really good solution on uh, how to ensure that first we cache all things and we don't DDoS the API like Helm does, and second, our cache is not stale. We react to changes and we delete everything from the cache, which Kubernetes API has, updated. So it's a lot of work here to do this strategic merge. I think it has value. Even if it overlaps a little bit with what customized controller is doing, is very different from customized, right? Because this uses live open API specs versus what customized has in the binary, which are hard coded. Containers, this one I merge because it's an array and I merge it. This one I don't, and so on, right? If you look in customized source code, everything is hard coded for, of course, and it only works with the built-in APIs, not CRDs, not anything. So
Well,
this
I
will
have support for loading
be way better.
an open API spec as well. Like I think we're just not using it, right? So if we were to build this for SourceWatcher, be tempting to allow it as an option on a customization.
The customization needs the file on disk.
For Discovery Client?
It can use a discovery client. So in the customization.yaml, you have CRDs as an array, and you need to give all the YAMLs on disk. That's how customized does it. There is a CRDs specification, and no one uses it because that means every single customized overlay has to bundle all the CRDs of all your controllers, everything. Right? I've never seen anyone using that feature. It comes with a massive pain. You need to spread your CRDs everywhere.
Whoever wrote that flag probably put that into a product somewhere, but yeah. Wouldn't be surprised if it's, part of some KRM pipeline in some Google thing.
Could be, yeah.
Or OpenShift or something, but yeah. Okay. But I think still, yeah, like if we find a good solution to this in SourceWatcher, it's potentially something to wire into customized build too. So I would also be tempted to add other merge methods that are offline and simpler than strategic merge patch, which is often very frustrating for people. It's like usually like when you're doing a merge, it's pretty intimate, right? Like you typically have like 1 or 2 patches and you're maybe like merging on something that you know and control. And if you look through the customized repo, like there's just like endless trawls of issues and comments from users like frustrated that they don't know how to make strategic merge patch work the way that they want it to. Because they don't control the open API spec, right? Like why would that one merge behavior be what you need all the time? One of the things I liked best about using YTT or JSONnet is that you can just do what you want, like just by saying what you want, So, or even in Puppet's Hyra, right? Like you can just say, hey, like, would you please append this? Which is a super common use case. Another use case here that could make sense would be even just concatenating the files together. Not structurally, but just like that or like how would you convince could you append a YAML node instead of like a root document node and not just a sublist item?
Yeah, for me, the major frustration with Customize was around Kubernetes service and ports in Flagger. It was like, he's saying, why can't I say I want to merge the array based on the port name? And the problem is name is not required
Yeah.
So it's not in the API spec. So it will always override the array. But I'm making it a requirement in my own system. Like
Yes.
Flagger will never generate a service with ports without names, right? So it was like, it's impossible to write a patch for
Mhm.
that. You
But
have to
yeah,
copy all the ports, right? And the patch is you have the final variant in your patch, so it will replace the array. Or the other option with JSON path, where you need to know exactly, you need to hard code the index of the port that you want to change. And you say, I want to change the port at index array 1. Now someone goes and adds a port above it, and there is no way to say you need to keep everything in sync with the array numbers, right? Which is so painful, given that, hey, I port names are required for me. This is the API I'm dealing with. Why can't I say merge by name? There is not an option, right? I was also thinking about this. What if we make like a strategic merge by name,
yes.
and you look in all the arrays? It doesn't matter if it's an array. Does it has a name called? Does it has a field called name? Use that to merge it, and that will cover like 99% of the use cases, and it will be way better than anything that customize over, just with a simple convention, right? If we offer this very opinionated merging strategy,
I
where
think
it's just this convention, you have a name somewhere, because everything is like that. Containers have a name, ports have a name, policies have a name, everything usually has a name, and that's usually in 99% of the cases the key that you want to use to do the strategic merge, right?
yeah,
So
or
yeah,
it host path, um, other identifier type things, ID, yeah, um,
yeah.
hash, SHA-256 sum, whatever, right? Like any unique identifier type field, you'd probably want to merge on that, and maybe in some sort of priority order. And yeah, that would meet a lot of people's use cases. I really feel like this is it's a little bit weird to be talking about like this sort of config merging and metaprogramming in the context of artifact generation, but really like it's starting to get into like a config management, you know, tool. Um, you might even want to just like be able to run this like fully locally, like with Flux build. And there might be some use cases for doing that and then putting it into an OCI repo. So it almost becomes its own customized like thing, you know. But yeah, merging strategies, it's like you just want the power there, and I've been endlessly frustrated with Customize since the very first day I used it. That it doesn't give you enough expression on what are really some very simple and sensible declarations, right? Like Customize lets you do things, and then like you find the edge case where it's like now you're trying to do the thing on a null node or an empty list or something that doesn't exist yet 3 paths down. And it's like the same exact declaration, but now it doesn't know what to do. Wild to me, you know. And just Kubernetes choice to use JSON patch in general. Like I get it, it's there, but like there's so many other things that you could have leaned on. Like
Yeah.
I came up with that idea today of adding a JQ preprocessor to Customize controller just to deal with all of Customize's shortcomings. You know, like just like serialize the whole blob and let people JQ on it before they throw it into Customize. Um, and so many people would be very happy with that because you're not doing anything wild with JQ. It's like pretty much the same type of tool as JSONet or Q or something, right? It's like you have a stream and a program and you get a declarative output hermetically. So
Yeah, I mean, none of this belongs in customized controller. If we are doing this kind of our own merges and stuff, Source Watcher is the place where you do it, because it's
cool. Yeah.
it's where you can, is the place where you can transform source artifacts into other source artifacts, right? And I don't think customized controller should alter in any way the source it receives,
Yeah, I
because
mean,
there is some trust in there that whatever you receive, you only have the customized definition, and that's the only thing that can change things, and not other stuff, which
if
is
we had a list merge in Source Watcher in external artifact, if that list merge was there, I could write a patch in my repo, and then use that list merge on, all of the files in a directory. Actually, that's an interesting thing, is copying to files with a blob. Is that supported? Like,
so the from copy from,
yeah,
it's glob.
yes, but like you can't do like a for loop type thing. Like I can't say apply this patch on a bunch of different files. I would have to list all the files.
Yeah,
Yeah.
I had to list them.
Kind of the same thing with resource set. Like you can't just like resource set off of everything in a folder. You also have to take all of those file names and then put them in your inputs in order to get the outputs. So that machine is still kind of not present. That would be incredibly powerful if you could do something like that. If you could create an artifact based off of a directory list or something.
Yeah, I mean, there is artifact generator is v1 beta 1. There is a lot of
Yeah, we can mess around with it.
space here. We
I-
can mess around with it as long as we don't break the existing functionality, because v1 beta 1 in Flux was always production ready. With the only, asterisk that yes, we could in the future deprecate fields and remove them, but we never change the behavior of existing fields. And we are never going to do that to a Flux API. But for example, now we have this strategy field, right? We have the freedom of adding whatever other types of strategies we think of, as long as we don't mess with the merge one that's already implemented, which is a one-on-one with what Helm does, right? So we can also add another field like strategy merge rules, where merge rules inside that struct, it will have something like
Target files.
key, and the key will be name, or will be ID, or will be SHA, or whatever. Then when you do merge, strategic merge, and if you have these merge rules enabled, it will merge all the arrays if they have a name in there, or if they have an ID in there, and so on, right? So we have the freedom of, coming up with good use cases that solves real problems for working with configuration in general, as long as we append to the current API and we don't mess up with the basics of what it does today. And it's very basic. It's like copy from here to here, merge or override, right? As long as we don't mess up with this core concept of copy and copy. I tried really, really hard to follow CP, the CLI. Like everything that you do with CP all the glob expressions, how it creates subdirectories or it copies into the root or everything. Like it's a one-on-one with CP, and it was really hard. CP is like damn complicated. I didn't thought it is. It is.
Yeah, I was going to ask this earlier and how confident we are from a security standpoint about our path parsing and path traversal and that sort of thing.
I'm more than confident.
Okay.
I will bet everything you can't escape it, because if you look at the source code, this is actually written from scratch. I'm not using any library, and is written based on OS root, which was introduced in Go 124, which deals with all the problems of symlinks, escape, path traversal, and so on. Everything is a root. So every copy operation creates a new file system, sets the root to the artifact root, sets the root to the source root. So it's impossible to exit in any directions. This is the new file system implementation in Go.
Nice.
And it's like, it's way harder to work with
It's
it. It doesn't have a walk. You need to do all sorts of things in order to work with root file systems there. But I think it was well worth the effort
so this is
because
backed
there is no escape.
by a virtual FS implemented in Go standard lib.
Yeah,
Okay, cool. Good enough for me.
yeah, yeah.
Yeah. That does inspire confidence. It seems like something that would survive a security audit. Think
Oh
it's
yeah.
important for us to be skeptical, but yeah, that's a good approach.
This is how I used AI for this project. I took the file system implementation, the copy, the layering, everything, and I gave it to all the AIs out there to do a security audit on them. No AI found anything. Anyway, people are way better than AI, so looking forward to a proper security audit. But there is nothing special here. Everything starts with
Yeah.
OS root open, and everything happens, all the operation happen within the Go file system root constraint. Nothing happens outside. I'm not using file path copy or anything. Everything is based on OS root. Um, so if there is a problem, it's probably in the Go implementation because I'm not
Yeah,
bypassing it. So yeah.
the from and to mimicking copy is really really good design. With the consequence being that two should always be only a single place. Um, and that it'll do a directory copy potentially. Um,
Yeah, we are handling double star as well.
but then
Because that's a major use case for copyright, where especially
versus
if you want
copy.
to create customized bases and overlays,
Yeah.
you need a double star because you want to say the base, let's say it's in a directory 10 levels deep, but you want to copy it at the root of the artifact. You don't want to copy all the directory structures and layer it inside the artifact. So that's where the double star comes into play, and it's so powerful and so nice. But of course, you can say just star, and it will copy the whole path, and you layer the whole path inside. So it's like I've tested this for many in many ways, like running copy the command. Also, Mateus did the same. Like, oh, this does not match what copy does. Like this expression, right? And we managed to get it in line with the copy CLI. Reading the copy source code, the CP source code, the C1. I don't recommend that to anyone.
No.
Yeah.
No, yeah, I wouldn't.
Figuring out the double star and how it behaved when you like, damn, like reading that stuff really hurt. Anyway, it's done.
I would faster go to one of the Rust re-implementations than read original CP. Um That sounds rough. Yeah, this
Well, we
is
are
gonna be
way off
some
time.
interesting use cases. Yeah, the only thing I have is just that today I'm doing the final recordings and edits for the basically the Flux 2.7 announcement for the KubeCon intermission. And I'm trying to figure out this is a very good conversation for me to understand deeply on the use cases of what we're intending, because I need to figure out how in few words to express how cool and important this is. And I'm thinking that this the I feel like the update should be mostly about this. Like we've done lots of stuff
Uh,
with Flux Operator, and but
yeah. I
in the
mean,
past couple of
hear
releases.
me out. You should read. I gave you the issue with prepare for Flux 2.7, where there are the highlights of what we are shipping.
Yes.
Um,
Yeah, I've looked at that. And that's how I found the external artifact
oh, okay.
stuff. It's just when you only have 1 minute to say things, it's like you have to choose, right? Like I'd love to like also talk about how big, the year of Gitless GitOps was, and find some way to might drop on the docu-series and talk about how we just met at FluxCon, and that there's our first API removals coming up and all of those things. But then like I won't be able to express like external artifact and artifact generator at all. And so that's it's like a trade-off. Like I have to choose like what not to say. And I
Right, right.
feel like this is kind of big from an architectural standpoint. We're making a new controller, right? We're allowing people to integrate with us more easily, because it's always been possible, but no one's ever really spent too much time on it, right? I guess there was the Pulumi controller for a little bit that ended up being Bitrot. And then like VMware Tanzu ended up integrating for a product, but that stuff never, like really got to many Flux users.
Yeah.
Um, so, but yeah, I mean, it's like, and then, yeah, it just makes it way more powerful for people. Like, this is an extensibility and performance thing, which is what Flux is all about.
Yeah, I'm really, really happy with the decomposition stuff that actually solves some really nasty performance issues when you don't want or can't afford investing in CI and OCI and Gitless GitOps. This gives you an elegant way out without losing visibility. Tracing is there, even Git commit status. So I'm really happy finally finding a solution to this problem, which was raised many years ago. The pull request with implementing this closes an issue open like 4 years ago. Around, oh, I want to split these things up. How can I do it? Right? So yeah. Hey, Adrian.
Hello, guys. Very interesting
Yeah.
discussion, I must say.
Cool.
Yeah.
Man, we are so over time. You want to talk about something?
No, I think we are over time enough. I will try to bring this up in the upcoming dev meeting. We can talk about it. Yeah.
Oh, cool.
Yeah.
Okay.
I'm just working on this thing that I think you saw. Yeah, this pull request. I'm working on it, trying to find a solution for what you mentioned.
Yeah, let's talk about it. I mean, what you have there with the labels, it's like I would close that. It will never go in because
Yeah. I know.
it nullifies everything that Flux is supposed to do, drift detection.
Yeah.
Everything
I'm
is
trying.
drifted if you label it, right? So,
Yeah, I know. I'm trying to see how to do that, how to spread all that information. Yeah, I'm thinking
yeah,
about different things. Yeah, we'll see.
cool. Cool. Okay, I think it's time to close it. We are way over time. Thank you, Kingdom, for staying with us for so long.
Yes, of course.
Cool. Okay,
Yeah.
see you next week. Hopefully, Flux will be released so we can celebrate.
Yeah.
Take care,
Bye.
guys.
Bye.
Bye.
Cheers,
Bye.
friends.